Light is the fastest thing there is. Nothing in the universe moves quicker, and nothing ever will. It crosses the distance from the Sun to the Earth in about 8 minutes. It reaches the next nearest star in a little over 4 years. To cross our own galaxy from one edge to the other, that same light needs 100,000 years, longer than our entire species has existed. And our galaxy is one among roughly 2 trillion. When you line those numbers up in order, something breaks. The fastest thing in existence, the thing we measure all distance against, is reduced to a crawl, a slow swimmer in a sea so large that most of it the light will never cross at all. We say the universe is big, the way we say the ocean is big, as if it were a thing we are slowly getting to know. It is not that kind of big, and the difference is the whole question. Tonight, we are going to climb outward from the ground under your feet, one step at a time, from the Earth to the Sun, to the galaxy, to the very edge of what we can see, and measure each step honestly against the one before it. By the end of this, you will understand why the comparisons work beautifully for a while, and then fail completely, why most of the universe is already moving away from us faster than light can cross the gap, and why the larger part of everything that exists is sealed off from us forever, no matter what we ever build. This is not a tour of how wonderful it all is. It is an honest measurement of how large and how far out of reach the universe really is. If this is the kind of question you came here for, a like or a subscribe helps more people find the channel, and it means a lot to me. Now, let us begin. Start with the one size you actually know. The Earth is about 8,000 miles across. Stand on it, and it is the whole world, the floor under everything, the largest thing your body will ever sit on, and at the scale of a human life that is enormous beyond any real sense of it. You could walk for the rest of your life and never cross a fraction of it. So the Earth is the measuring stick we are going to carry the whole way out, and the first thing to do with a measuring stick is to set it against something and see how it compares. So set the Earth against the Sun. The Sun is about 109 Earths across. Not 9, not 19. 109 of them laid edge to edge would just span the width of it. And width is the gentle version of the comparison, because volume grows much faster than width. By volume, you could pour more than 1 million Earths into the Sun and still have room left over. The thing that holds up the entire sky, that every living thing has organized itself around, that sets the length of your day and your year, would vanish into the Sun like a grain of salt into a swimming pool. And the Sun is not close. The light that is warming your face right now left the surface of the Sun 8 minutes and 20 seconds ago, and it has been traveling the whole time at the fastest speed anything can travel, crossing 93 million miles of empty space to reach you. When you look at the Sun, you are not seeing it as it is. You are seeing it as it was 8 minutes ago, because that is how long even light needs to make the crossing. The nearest star to our planet, the one we call our own, is already 8 minutes away at the speed of light. Here is the fact that resets the whole picture. The Sun holds more than 99% of all the mass in the entire solar system. Not most of it, nearly all of it. Every planet, every moon, every asteroid and comet and ring and speck of dust, the Earth included, everything that is not the Sun, adds up together to less than 1% of the whole. The solar system is the Sun, and then a thin scattering of leftover crumbs going around it. We think of ourselves as living in a family of worlds. We live in the rounding error of a single star. There is something worth pausing on in that 8-minute delay, because it is the first appearance of a theme that runs all the way to the end of this. You never see the Sun as it is, you see it as it was 8 minutes ago, because that is how long its light needs to reach you. If the Sun were somehow switched off this instant, you would notice nothing wrong for 8 full minutes, living out those minutes under the light of a star that was already gone. And this is true of everything overhead, more so the farther out you look. The moon you see is 1.5 seconds old. The other planets are minutes to hours old. Every star is years to thousands of years old. To look out into space is to look into the past, and the deeper you look, the older the view becomes. By the end of this climb, that delay will have grown to billions of years, and it will stop being a curiosity and become the very thing that seals us in. And about that ordinary star, it is worth being precise, because the truth is stranger than simply calling the sun average. Most of the stars in the galaxy are not like the sun at all. They are smaller, dimmer, cooler red dwarfs, so faint that not one of them can be seen with the naked eye from Earth, no matter how dark the night. The sun is actually larger and brighter than the great majority of stars that exist. But the stars you can pick out and name, the ones bright enough to form the constellations, are the rare giants and the hot brilliant ones, many of them larger than the sun by far. So the sun sits in a strange middle, larger than most stars that exist, lost among the few you can actually see. Either way the conclusion holds. The object that contains 99% of our entire solar system is, by any measure that counts, one ordinary star among hundreds of billions. The sun makes its light by destroying itself, slowly and steadily. In its core, under crushing pressure and a temperature of around 27 million degrees, hydrogen is fused into helium, and in that process the sun turns about 4 million tons of its own mass into pure energy every single second. 4 million tons a second, poured out as light and heat, and it has been doing this for 4.5 billion years and will go on doing it for billions more, because there is simply that much of it to burn. The light reaching your skin took a strange road to get free. A flash of light born in the core can take tens of thousands of years to fight its way out to the surface, absorbed and thrown out again countless times through the dense layers above, so that the sunlight warming you now began, in a sense, before there were cities on Earth. It is worth grounding how large the Earth itself feels, so the shrinking has something to push against. The Earth is about 25,000 miles around. A jet airliner flying without stopping needs around 2 days to circle it once. A person walking without rest would need most of a year. From the ground it has no edge you can find, no end you can walk to. Every ocean and mountain range and country sits on this one ball, and for the whole of human history it was, for every practical purpose, the entire stage of existence, too large to cross with ease, and too large to feel as a single object at all. That is the thing, genuinely enormous by every human measure, that vanishes into the sun like one grain into a drift of sand. We are not starting this climb with something small. We are starting with the largest thing any of us will ever stand on, and watching it disappear at the very first step. The sun is not solid, and there is nowhere on it to stand. It is a ball of plasma, gas so hot that its atoms have been torn apart, with a visible surface that is not a surface at all, but simply the layer where it becomes transparent, churning at around 10,000 degrees. Below that the heat climbs without pause toward the 27 million degrees of the core. There is no ground anywhere in it, no point you could ever touch, only deepening shells of furious hot gas the whole way down. The bright disk we picture is a boiling sphere of fire 109 Earths wide, held together by its own gravity, steadily turning itself into light. And it will not last. In about 5 billion years, the sun will run out of the hydrogen in its core and swell into a red giant, growing until it swallows the inner planets, very possibly including the Earth, before it collapses into a dim cinder the size of our planet that will cool for the rest of time. The star that dwarfs us and warms us and anchors everything we are is itself temporary, with a beginning we can date and an ending we can predict. But even the death of the sun is a local matter, 5 billion years off, and small against the scale we are climbing toward. I raise it only to be clear that nothing here is permanent, not even the one star our whole world depends on. Here is a coincidence of scale that happens to fall in our own time. The sun is about 400 times wider than the moon, and it also happens to sit about 400 times farther away, which means the two appear almost exactly the same size in our sky. That is the only reason a total eclipse looks the way it does, the moon sliding across the sun and covering it almost perfectly, one disk laid over another. There is no law behind it. It is a passing accident of where the moon happens to be in its slow drift away from us, true now and not true in the deep past or the far future. We live in the narrow stretch of time when the numbers line up, and we are quick to read meaning into it, but it is only the scale of things briefly agreeing by chance. And the sun itself, seen from any distance worth mentioning, is nothing to pick out. From the nearest star, 4 light years off, the sun would be an ordinary point of light. One more star in that sky, neither the brightest nor the dimmest, with nothing to mark it as the anchor of a living world. From across the galaxy it would be wholly invisible, lost among the hundreds of billions. The star that fills our sky and rules our days does not stand out at all once you step back even the first short distance. It is bright to us for one reason only, that we sit close beside it, and that closeness is the whole of its distinction. Consider how little of even the sun's light ever does anything at all. The sun pours out its energy in every direction at once, a full sphere of light streaming outward, and the Earth, 93 million miles away, is a target so small that it catches only about 1 part in 2 billion of the total. The rest, very nearly all of it, races off into space and strikes nothing, crossing the emptiness between the worlds and then the far greater emptiness beyond, most of it never landing on anything ever. The star that gives us everything gives us a rounding error of itself, and the overwhelming majority of its light is simply lost to the dark. Even at the scale of a single ordinary star, almost all of what happens in the empty space, and only the faintest sliver of it ever touches a world. And the sun's reach does not end at its surface, or even at the planets. Its gravity holds sway over that distant shell of comets, the Oort cloud, which may stretch a quarter of the way or more toward the nearest star. By that measure, the sun's true domain is not 109 Earths wide, but something closer to light years across, a near empty sphere of space in which the sun's pull is still, just barely, the strongest force. And even that enormous domain, light years of space ruled by a single star, is one small bubble pressed up against the bubbles of the neighbouring stars, all of them packed into one minor spur of one arm of a galaxy 100,000 light years wide. The sun is large, and its reach is larger still, and both of them vanish at the very next step out. And I want to be honest about what kind of star it is, because this is where the scale starts to turn. The sun is not a giant. It is not a special or a powerful star. As stars go, it is utterly ordinary, a middling yellow star of middling size, the kind the galaxy holds in their hundreds of billions, dimmer and smaller than many of the stars you can see by eye on a clear night. The thing that swallows 1,000,000 Earths without noticing is itself one of the most unremarkable objects in the sky. We have not even taken a real step yet. We have compared the Earth to the single nearest, most average star, and the Earth has already disappeared. So the question that pulls us outward is simple. If the Earth vanishes beside one ordinary star, what happens when we step out into the distance between the stars themselves? The empty space between things in space is larger than the things, and the very first gap proves it by defeating our fastest machine. There is an object called Voyager 1, a small probe launched outward from Earth almost 50 years ago, and it is the most distant thing human hands have ever made. It has been flying away from us this entire time, faster than anything else we have ever launched, never stopping, never slowing in any way that matters, for nearly half a century. Right now it is about 16 billion miles from the sun. That number sounds like the edge of everything. It is not. It is barely the doorstep. Voyager 1 is now so far that its radio signal, travelling at the speed of light, takes around 22 hours to reach us. A message from it is nearly a day old by the time we hear it. And after almost 50 years and 16 billion miles, it is nowhere near leaving the Sun behind. The Sun's true outer realm, a shell of icy debris called the Oort cloud, is thought to begin far beyond where Voyager is now, and to reach perhaps a quarter of the way to the next star, and possibly further. Voyager has not reached the edge of the solar system. It has not reached the edge of the Oort cloud. It has, after a human lifetime of flight, barely cleared the planets. Now hold that against the distance it would actually need to cross to get anywhere. The nearest star to our Sun, Proxima Centauri, sits 4.24 light-years away. Light, the fastest thing there is, takes 4 years and 3 months to get there. Voyager, our fastest machine, moving at a speed that flung it past every planet, would need around 70,000 years to cover that same gap. 70,000 years. Our entire recorded history, every city and empire and written word, fits many times over inside the time it would take our best probe to reach the single closest star. And Proxima is the easy one. It is the nearest star there is. So the picture of the solar system as a crowded place, planets wheeling close together in a busy little neighborhood, is wrong in a way that matters. The solar system is almost entirely emptiness. If you shrank the Sun down to the size of a beach ball, the Earth would be a grain of sand some tens of yards away, and the next beach ball, the nearest other star, would be thousands of miles off, with nothing in between but dark and cold and a few more grains of sand. The space is not the gap between the interesting parts. The space is the main thing. The worlds are the rare exceptions scattered through it. Voyager 1 left Earth in 1977, and to give a sense of its speed, it is moving at around 38,000 miles an hour, fast enough to cross the whole of the United States in under 5 minutes. In 2012, after 35 years of flight, it finally crossed the boundary where the Sun's wind of particles thins away into the gas between the stars, the edge of the bubble we call the heliosphere, and passed into interstellar space. That sounds like leaving. It was not. It had left the Sun's wind behind, but not the Sun's gravity, the icy shell of comets that the Sun still holds in its grip. The Oort cloud lies enormously far beyond it, and Voyager will fly for tens of thousands of years before it even reaches the inner edge of that shell, never mind passing through to the far side. You can feel the emptiness in the timing of light across our own solar system. Sunlight reaches Earth in 8 minutes. It reaches Jupiter in about 43 minutes. Out at Neptune, the most distant major planet, sunlight arrives roughly 4 hours after it leaves the Sun. 4 hours just across our own family of planets at the fastest speed there is. And then, past Neptune, the timing does not creep up to days or weeks before the next thing out there. It leaps to years. The nearest star is over 4 years of light away. The gap between the last planet and the next star is not one more step up from the gaps between planets. It is a different order of distance altogether, an ocean of empty dark in which the entire planetary system was a single drop. Between the planets and that distant comet shell lies another zone, the Kuiper Belt, a broad ring of icy worlds out beyond Neptune where Pluto makes its slow orbit. Sunlight takes about 5.5 hours to reach Pluto, and from out there the Sun would not be a disk in the sky at all, but simply the brightest star, a fierce point of light giving almost no warmth. Stand on Pluto and you would see a sky that looked like deep night even at noon, lit by a sun shrunk to a brilliant spark. And Pluto, far as it is still practically on our doorstep. It is still inside the planetary region, still washed in recognizable sunlight, still nowhere near the true edge of the Sun's realm. Put the whole thing into a model you can hold in your head. Shrink the Sun to the size of a beach ball and set it down in a field. On that scale, the Earth is a grain of sand about 100 feet away, and the entire crowd of planets fits within a few hundred yards, a handful of specks around a ball. Now place the nearest other star on that same scale, the next beach ball. It would not be in the next field or the next town. It would be more than 4,000 miles away, a beach ball on the far side of an ocean with nothing in the enormous space between the two but a few drifting grains and the dark. That is the real texture of our corner of the galaxy. Two beach balls, an ocean apart, and almost perfect emptiness in between. Voyager carries a golden record fixed to its side, a disk of sounds and images from Earth, placed there in case anything ever finds it. It is a moving gesture and also a quiet measure of the odds, because the chance of anything ever coming across it is so near to zero as to be indistinguishable from it. The probe is not aimed at any star, it is simply falling outward through the dark, and in around 40,000 years it will pass within a couple of light years of another star, which is to say it will miss that star by a distance still thousands of times wider than our entire planetary system. That is as close as our most far-flung creation will ever come to another sun, and it is not close at all. The space it is crossing is emptier than any vacuum we can build on Earth. Between the stars there is on average about 1 atom in every cubic centimetre, a thinness so extreme it would count as a flawless vacuum in any laboratory we have. For light years in every direction around Voyager, there is essentially nothing, no dust to speak of, no warmth, no light but the distant, unwavering stars, and a cold near the lowest temperature there is. This is the stuff that fills the gaps between the stars, and it is almost pure emptiness, and it is the overwhelming majority of what the galaxy is made of. The stars are the rare, dense flecks. The galaxy is mostly this, the thin, cold dark stretch between them. And there is no near fix for this through speed. Suppose we built something that could fly at 1/100th of the speed of light, far past anything we can currently approach, fast enough to cross from the sun to the Earth in under a day. Even that machine would need over 400 years to reach the nearest star, longer than the time since the telescope was invented, carrying a crew who would have to live and die and be born again many times over along the way. The gap to the very nearest star is not a problem a better engine solves. It is wide enough that even speeds we have no idea how to reach would stretch the crossing into centuries. The emptiness does not give way to cleverness. It is simply too large, and it is the smallest gap of its kind we will ever face. And to actually cross even that nearest gap, a ship would have to become a world in itself. No one who set out would arrive. The crossing to the nearest star, at any speed we can seriously build toward, would take longer than the whole of recorded history, which means the travellers would have to live their entire lives aboard, and their children after them, and their children's children, for generations, all of them born and dying in the dark between two suns, the destination never more than a faint star ahead, slowly growing brighter across hundreds of years. That is what the very first gap asks of us, the easy one, the short one, the nearest star there is. Everything past it asks far more, and most of it asks for the plainly impossible. To put Voyager's 16 billion miles in the only terms that really matter out here, it is not even 3 light days from home. Light covers that entire 50-year distance in under a day. The achievement we are proudest of, our farthest reach, our deepest probe into the dark, sits at a distance that light shrugs off between one sunrise and the next. That is the true measure of the gap between what we can do and what the distances actually are. We have spent half a century flinging our best machine outward, and it has gone a few light hours, in a galaxy measured in light years, and a universe measured in billions of them. And here is the honest admission underneath all of this. We have never sent anything even a measurable fraction of the way to another star. Not close. Voyager, for all its distance, has covered a sliver of a % of the way to Proxima, and it will be dead and silent for tens of thousands of years before it ever arrives, if it happens to be pointed anywhere near it, which it is not. The gap between one sun and the next is for us completely untravelled and for now untravelable. So if a single gap between two stars is enough to defeat us this completely, what are we to make of the galaxy, which is not one such gap, but built out of hundreds of billions of them? The Milky Way is so large that light itself, the thing that reached the nearest star in 4 years, needs 100,000 years to cross it. Take that in slowly, because it is the first number that truly breaks the scale we have been using. We measured the distance to the sun in minutes of light, and the distance to the next star in years of light. The galaxy we live inside is 100,000 years of light from one edge to the other, a beam of light setting out across the Milky Way when the first modern humans were appearing on Earth would only now be arriving at the far side. Inside that span are somewhere between 100 billion and 400 billion stars. We cannot give you a sharper number than that, a range that wide, because we cannot even count the stars in our own galaxy directly. Each one of them is a sun. Many of them hold worlds, and our sun, the star that swallows 1,000,000 Earths and holds 99% of everything around us, is one single unremarkable member of that enormous crowd, sitting about 26,000 light-years out from the centre, far from anything important on a minor spur of one of the spiral arms. The motion at this scale is its own kind of vertigo. The sun is not sitting still, it is orbiting the centre of the galaxy, dragging all of us with it, at around 500,000 miles an hour, and even at that speed a single lap around the galactic core takes about 225 million years. That span has a name worth holding on to. It is one galactic year. The sun has been alive for only about 20 galactic years. The last time the sun was in this exact spot on its orbit, the ancestors of the dinosaurs were just appearing on Earth. The time before that, there were no animals on land at all. The galaxy turns so slowly that a single one of its years swallows the whole history of complex life. And almost none of it is visible to you. Go out on the darkest, clearest night, far from any city, and look up at what seems like an overwhelming field of stars. You are seeing a few thousand of them, a few thousand out of hundreds of billions, and every single one of those few thousand is a near neighbour, practically next door, all of them huddled close around our sun, in one tiny corner of one arm. The glowing band we call the Milky Way, the faint river of light across the sky, is the combined glow of countless more stars, too far and too dim to separate by eye, and even that is only the nearest slice of the galaxy we happen to be looking through. At the centre of all that turning, 26,000 light-years from us, sits something we cannot see directly but have weighed with precision by watching stars whip around it at enormous speed. It is a black hole called Sagittarius A star, holding the mass of about 4 million suns in a region smaller than our solar system. The entire galaxy, all of those hundreds of billions of stars, turns around that dark centre the way the planets turn around the sun, and our own star has been circling it for the whole of its life, carrying the Earth along a path so large that we have completed only about 20 laps of it since the sun first ignited. Hold one of those laps against the history of the Earth, and it lands hard. 225 million years ago, the last time the sun sat where it sits now on its orbit, the continents were fused into a single landmass. There were no flowers and no birds, and the first dinosaurs were only beginning to appear. The sun has not made one full circuit of the galaxy since then. 1 galactic year ago, the world was unrecognizable. 2 galactic years ago, life had barely crawled onto the land. The galaxy turns so slowly and is so large that a single one of its years contains nearly the whole story of complex life on Earth. There is far more to the galaxy than the stars, and most of it cannot be seen at all. The stars and gas of the Milky Way are wrapped in a much larger halo of dark matter, an unseen substance we detect only through its gravity, and which outweighs every star combined by something like 5 or 6 to 1. The shining galaxy, the part that gives off light, is the minority of what is there. The bright spiral we picture, the hundreds of billions of stars, sits embedded inside a far larger ball of something we cannot see and do not understand, holding the whole structure together and keeping it from tearing itself apart as it turns. And around those stars are worlds beyond counting. The number of planets in the galaxy is thought to be at least as large as the number of stars, and probably larger, which puts it past 100 billion at the low end and well beyond a trillion at the high. Most stars have planets, many have several. The galaxy is not a field of suns with a few scattered worlds here and there. It is hundreds of billions of suns, most of them holding worlds of their own, and almost every one of those worlds is a place no eye will ever see, and no craft of ours will ever come close to reaching, lost in a galaxy too large to cross. The spiral arms that give the galaxy its shape are not fixed pinwheels of fixed stars. They are closer to waves, regions where stars and gas pile up for a while as they orbit, lit by the bright young stars born in the crowding, so that the arms glow while individual stars drift in and out of them over time. The sun is not locked to an arm. It weaves slowly through them along its long orbit, and right now it sits in a minor structure between two larger arms, in a fairly quiet and ordinary stretch of the galaxy, which is part of why we are here at all, well away from the violent crowded regions near the core. And through all of it we are moving at tremendous speed without feeling a thing. The Earth is turning at up to 1,000 miles an hour, circling the Sun at around 67,000 miles an hour, while the Sun carries the whole system around the galaxy at close to 500,000 miles an hour, and the galaxy itself is falling through space toward Andromeda and the Great Attractor faster still. You are, right now, being hurled through the galaxy at a speed no machine of ours can match, and you feel perfectly still, because everything near you moves along with you, and there is nothing close enough to measure the motion against. The stillness you feel is only the absence of anything nearby to compare yourself to. Look at our own immediate stretch of the galaxy, and the emptiness holds at every scale. Within about 16 light-years of the Sun, there are only around 50 stars, and most of them are dim red dwarfs far too faint to see, scattered through a volume so large that the distances between them dwarf everything in the solar system. These are our neighbours, the closest stars there are, and they are years of light apart, divided by the same cold near vacuum that Voyager is still crawling through. There is no dense cluster nearby, no crowd of suns close at hand. There is only a thin scattering of stars in the dark, our own among them, with enormous gaps between every one. And the galaxy that holds them is not the solid pinwheel it looks like in pictures. The bright disk of the Milky Way is about 100,000 light-years across, but only around 1,000 light-years thick, which makes it, in proportion, thinner than a sheet of paper. It is a flattened spiral, wide and shallow, with the stars spread so sparingly through even that thin disk that two whole galaxies can pass straight through one another, as ours and Andromeda one day will, without more than a handful of stars ever striking each other. Even where the galaxy looks crowded and bright, it is mostly the space between the stars. The galaxy is old too, nearly as old as the universe itself. Its oldest stars formed more than 13 billion years ago, not long after the beginning, and many of them still drift through it now, scattered in a faint outer halo and gathered into tight ancient swarms called globular clusters that orbit far above and below the disk. So the Milky Way is not only enormous across, it is deep in time, holding stars that were already old when the Sun was born, stars that have circled the dark centre hundreds of times over while whole eras rose and fell, unseen on a planet that did not yet exist. The galaxy has been turning and making and burying its stars for very nearly the entire age of everything there is. The faint band of light we call the Milky Way, the one that gives the galaxy its name, is simply our view of the disk seen from inside it. We sit within the flat plate of stars, so when we look along the plate toward its crowded depths, the combined glow of countless distant stars blurs into that pale river across the sky. When we look the other way, out through the thin face of the plate, we see fewer stars and darker sky. The shape of our night is set by our position inside the disk, looking out through it in some directions and along its length in others. The galaxy is not above us or around us in the way a sky is. We are embedded in it, a single point inside the thin bright sheet, seeing it the only way you can ever see a thing you are standing inside. There is an honest limit here too. We cannot actually see most of our own galaxy. The center and the far side are hidden behind thick lanes of dust and gas, and much of what we know about the shape of the Milky Way, its arms and its bar and its true breadth, is pieced together by inference and by reading other galaxies, because we are stuck inside this one and cannot get a clear look at it from outside. We live in it and we still cannot see it whole. So we are tempted, standing here, to think this is most of it. Hundreds of billions of stars, 100,000 years of light across. Surely this is close to the whole of things. It is not. The galaxy is one. The only question left is, one of how many? Our entire galaxy, all of those hundreds of billions of stars, is one island among roughly 2 trillion others. That is the number that ends any remaining sense that the Milky Way is the universe. 2 trillion galaxies, and each one of them is itself an island the size of the one we just struggled to take in, 100,000 light years across, holding its own hundreds of billions of suns. We are not looking at more stars now. We are looking at more galaxies than there are stars you could ever see by eye. Each galaxy a Milky Way of its own. Begin with the nearest large one, because even the first step into this is already past comprehension. The Andromeda Galaxy is the closest major galaxy to ours, and it is 2.5 million light-years away. The light reaching your eye from Andromeda tonight, if you find it as a faint smudge in a dark sky, left that galaxy 2.5 million years ago, before our species existed. You are looking at light older than humanity, from the nearest big thing outside our own galaxy. And Andromeda is a neighbor. It is part of our own small cluster. That cluster has a name. It is the Local Group, a loose collection of dozens of galaxies bound together by gravity, spanning about 10 million light-years, dominated by the Milky Way and Andromeda, with a scattering of smaller galaxies around them. 10 million light-years, dozens of galaxies, and this is just our immediate neighborhood, the few houses on our own street. The Local Group is one of countless such groups, and the groups gather into larger structures, and those into larger ones still, all the way up to that total of around 2 trillion galaxies in the part of the universe we can see. Then there is the count of stars, which stops being a number you can hold at all. Across those 2 trillion galaxies, the best estimate of the total number of stars is around 10 to the 24th. That is a 1 with 24 zeros after it. The way it is usually put is the only way that lands. There are more stars in the observable universe than there are grains of sand on every beach and in every desert on the entire Earth, all of them added together. Every grain of sand on every shore you have ever walked, and the count of stars is larger than that. And around a great many of those stars are worlds, more worlds than there are sand grains on Earth, almost all of them never to be seen by anyone. Andromeda is not only the nearest large galaxy, it is coming toward us. It and the Milky Way are falling together under their own gravity, closing at around 250,000 miles an hour, and in roughly 4.5 billion years the two will collide and begin to merge. They will not crash the way two solid things crash, because galaxies are mostly empty space, and almost no stars will actually strike one another. Instead, the two great spirals will sweep through each other, pull one another apart over hundreds of millions of years, and eventually settle into a single larger galaxy. By the time that happens, the sun will be nearing the end of its own life, and the sky over whatever remains of Earth will be lit by the slow wreckage of two galaxies becoming one. The best way to feel the number 2 trillion is to point a telescope at nothing. There is a patch of sky, in one famous attempt no larger than a grain of sand held at arm's length, that looked completely empty, no stars, no glow, only black. A telescope was aimed at that blank speck and left to gather the faintest light for days on end. What came back was not darkness, it was thousands of galaxies, crowded into that one tiny empty-looking patch, each a city of hundreds of billions of stars, not one of them visible to the eye, all of them billions of light-years away. And that patch was chosen almost at random. Point at nearly any seemingly empty scrap of sky, and the same thing waits behind the dark. The whole sky, in every direction, is packed with more galaxies than we can count, hidden only because their light is too faint and too far to register where our eyes could catch it. The local group has its two large galaxies, the Milky Way and Andromeda, and then a long tail of smaller ones. Two of them, the Magellanic Clouds, are close enough companions of our own galaxy to be seen with the naked eye from the southern sky, faint patches of light that are in truth entire dwarf galaxies of hundreds of millions of stars each. A third sizable spiral, the Triangulum Galaxy, sits out near Andromeda. The rest are dwarfs, dozens of them scattered through that 10 million light-year span, and this whole collection, our entire gravitationally bound family of galaxies, is the thing that survives into the far future after everything else has gone. Hold on to that, because it comes back later as the last island left in an empty sky. Try to count to trillion and the number defends itself against you. If you counted one galaxy every second, never sleeping, never stopping, it would take you more than 60,000 years to reach 2 trillion. 60,000 years of counting, one per second, merely to number the galaxies, and that is before you count a single one of the hundreds of billions of stars inside any one of them. We do not count them. We estimate them in great statistical sweeps, because there is no other way it could be done. The individual galaxies, each one a structure as large and as intricate as the whole system we live inside, are simply too many to be counted one by any species in the time that species is likely to last. When the deepest of those images was made, a tiny patch of sky stared at for the equivalent of many days of gathered light. It collected around 10,000 galaxies in a portion of the sky so small that it would take millions of such patches just to cover the whole dome above you. Multiply it out, and you arrive once more at the same impossible total, hundreds of billions to trillions of galaxies, confirmed not by counting them all, but by counting one tiny sample, and recognizing that the sample repeats everywhere you point. The dark between the visible stars is not empty at all. It is crowded with galaxies too faint to see, layered back and back toward the beginning of time. And they are not all alike. There are grand spirals like our own and like Andromeda, slow-turning disks laced with arms of young stars. There are enormous elliptical galaxies, built from ancient collisions, swarms of old red stars with no real shape. There are small, ragged, irregular galaxies, torn and lopsided. The light from the most distant of them shows them young and still forming, because we see them as they were billions of years in the past, while the light from nearer ones shows them grown old. The sky is not only full of galaxies, it is full of galaxies at every stage of their lives at once, all of it reaching us together as light of a billion different ages, a single view assembled out of countless separate pasts. Set the light from Andromeda against the clock of our own kind to feel the size of the gap. The light reaching your eye from that galaxy tonight left it about 2.5 million years ago, when our ancestors were not yet recognizably human, when nothing on Earth had built or written or spoken a single word. It crossed the space between two galaxies unhurried, the whole of human history unfolding in a sliver of its travel time, and it arrives only now. And Andromeda is the near one, the closest large galaxy there is. The light from the more distant galaxies in our sky left them before the Earth itself had even formed. To look out into the field of galaxies is to look across stretches of time that swallow not only human history, but the entire history of the planet. The light always older, the farther out it has come from. Between the loose local group and the great supercluster lies a rung we passed over, the galaxy cluster. Galaxies gather by the hundreds and the thousands into clusters bound tightly together by gravity, and the nearest large one, the Virgo cluster, sits about 50 million light-years away and holds well over 1,000 galaxies in a single swarm. Our own local group is being drawn toward it, falling slowly inward as part of the larger flow. These clusters are the largest things in the universe, still held together firmly enough to resist the expansion. Inside them, galaxies will stay bound for as long as they last. Outside them, in the space between the clusters, the expansion is winning, the gaps are widening, and that space between is most of the universe. And the nesting goes on, each level quietly holding the one below it. Moons orbit planets, planets orbit the sun orbits the galactic center, the galaxy drifts within the local group falls through Laniakea, and Laniakea streams toward the great concentrations beyond. At every step, the thing that had felt like the whole turns out to be a small part of something larger, and the pattern does not stop until it runs into the limit of what we can see at all. Nowhere on the way up is there a level that is clearly the top, a larger structure that finally contains everything else. There is only structure within structure, out as far as the light reaches, and then the horizon, and then the unknown beyond it. By the time you reach this rung, the galaxy has quietly become the unit, the single countable thing, the way a star was a few steps ago, and a planet before that. Astronomers speak of galaxies the way we speak of grains of sand or drops of water, in the bulk, by the billion, because there is no other sane way to handle a number like 2 trillion. A single one of them, our own, holds every star you have ever seen and every star you never will, the whole of the night sky and hundreds of billions more behind it, and the climb has reduced it to one dot among an uncountable scatter. That is what each step out here does. It takes the largest thing you have just managed to picture and turns it into the smallest unit of the next level up. I have to be honest about that figure of 2 trillion, because the channel does not paper over the soft numbers. It is genuinely uncertain. It came from one careful study, and more recent work using newer data argues the true number may be lower, perhaps a few 100 billion galaxies rather than 2 trillion. The honest answer is that we do not know the exact count, and reasonable researchers disagree. But notice that the disagreement is between hundreds of billions and trillions. The argument is over which unimaginable number is correct. The scale itself is not in any doubt, and this is the point where I find the whole thing stops feeling like wonder and starts turning into something colder, because we are running out of ways to make these numbers mean anything, and we are about to run out completely. Past the galaxy, the ladder breaks. Every comparison that carried us this far, the Earth against the Sun against the galaxy against its neighbours, has worked because each step was a clean multiple of the last, a number you could just barely stretch your mind around. That stops here, and it is worth being honest about the moment it stops rather than pretending the mind can keep climbing forever. Our local group, those dozens of galaxies spanning 10 million light years, turns out to be a single small knot at the outer edge of something far larger. That larger structure is called the Laniakea supercluster. It is about 520 million light years across, and it contains roughly 100,000 galaxies, the Milky Way among them as one quiet dot near its border. And the whole enormous structure is in motion, all of those 100,000 galaxies, slowly streaming toward a single region inside it, pulled by a concentration of mass so large that it has a name, the Great Attractor, and yet we cannot see it clearly because it lies in the one direction where our own galaxy's dust and glare block the view. We are being pulled, along with 100,000 galaxies, towards something we cannot even properly look at. Then you pull back far enough to see how the galaxies are arranged across these distances, and the last comfortable idea falls away. They are not spread evenly through space like stars across the sky. They are strung into threads and sheets, long glowing filaments of galaxies wrapped around enormous dark hollows where there is almost nothing at all. The structure of the universe at the largest scale looks like a web or like foam, dense walls of galaxies enclosing immense empty bubbles. And those empty bubbles, the voids, are not the gaps in the structure. By volume, they are most of the structure. Most of the universe, by far, is the empty part. Consider one of them directly. In the direction of the constellation Bootes, there is a region of space called the Bootes Void, and it is about 330 million light-years across. Inside that enormous sphere, astronomers have found around 60 galaxies. A normal patch of the universe that size would hold something closer to 2,000. It is not truly empty, but it is empty enough that the scale of it does something to the mind when you state it plainly. One astronomer who studied it put the emptiness like this: if the Milky Way had been sitting at the center of the Bootes Void, we would not have discovered that other galaxies existed at all until the 1960s. We only learnt that Laniakea existed as a single structure a little over a decade ago, when astronomers mapped the motions of thousands of galaxies and found that all of them, across 500 million light-years, were drifting along the same enormous flow, like water sliding toward the same valley floor. They gave it a Hawaiian name meaning immeasurable heaven. That is the structure we belong to, and we did not even know it was one thing until recently, because we sit inside it and cannot step back far enough to see its shape. Even the largest structure we are part of is something we have to read from the drift of distant galaxies rather than simply look at directly. And Laniakea is one supercluster among a great many, all of them strung along the same web. The largest single structures we have found in that web run past easy stating. One of them, a sheet of galaxies called the Sloan Great Wall, stretches across something like 1 billion light-years, a wall of galaxies so long that light needs 1/10 of the entire age of the universe just to cross its length. Between these walls and threads lie the voids, the empty bubbles, and the walls themselves are thin by comparison. Stand back far enough, and all the bright matter, every galaxy and every star within them, is a delicate film stretched around immense pockets of nothing. The nothing is the bulk of it. The galaxies are only the foam clinging to the surface of the hollows. Come back to the Bootes Void and make the loneliness of it concrete, because this is the heart of what the scale actually means. A galaxy near the center of that emptiness would have, as its nearest neighbor, another galaxy tens of millions of light-years away, so distant it would be a barely detectable smudge if it could be found at all. Its sky would hold its own stars in their hundreds of billions, and beyond them, in every direction, an almost perfect darkness running out for hundreds of millions of light-years before the next wall of galaxies began. Any astronomer born there would build their whole picture of reality out of a single galaxy, with no reason to suspect that 2 trillion others existed, or that they hung in glowing threads around hollows like the one their entire world sat lost inside. The emptiest places are not the strange exception in this universe. By volume, they are the ordinary case, and a mind inside one would reasonably call the surrounding darkness the whole of everything there is. The flow that defines Laniakea has a destination. All of those 100,000 galaxies, ours among them, are streaming toward a region called the Great Attractor, and past it toward an even denser pileup of galaxies called the Shapley Supercluster, the largest gathering of galaxies anywhere near us. We are falling toward the richest concentration of matter within reach, at around 1 million miles an hour, and we will never arrive, because the expansion of space will pull these structures apart long before the flow could ever carry us there. We are being drawn toward a place that we are at the same time being separated from forever. The pull and the loss are happening together. And the lesson of the voids only sharpens as the maps get better. By volume, something like 4/5 of the universe is void, those empty bubbles, with the galaxies pressed into the thin walls and threads between them. If you were dropped at a random point in the universe, the overwhelmingly likely result is that you would find yourself adrift in a void, tens of millions of light-years from the nearest galaxy, in a darkness so complete that the night sky around you would hold nothing at all, not one point of light. The crowded, star-filled sky we treat as simply what a sky is, turns out to be a rare local condition, the view from inside one of the bright walls. Most places in the universe have no such view. Most of it is the dark between. Part of why the Great Attractor stays a mystery is simply that our own galaxy is in the way. The thick band of the Milky Way, dense with stars and dust, blocks a whole strip of the sky we call the zone of avoidance, and the Great Attractor lies almost directly behind it, hidden from a clear view by the very galaxy we are trying to see out from. So the thing dragging our entire supercluster of 100,000 galaxies across space is something we have had to study by squinting around the edges of our own galaxy, catching pieces of the mass beyond. We are being moved by something we cannot properly look at, in a direction we cannot clearly see. And the structures only grow as we map further out. Beyond the Sloan Great Wall there are still larger candidate structures, arcs and walls of galaxies stretching across billions of light years, some so large they strain the rules for how big anything is supposed to be able to get. At these sizes, the comparisons have not merely become hard, they have failed outright. There is no object in human experience, nothing you have ever seen or held or stood beside, that can be set next to a wall of galaxies a billion light years long. The measuring sticks we began with, the Earth, the light minute, the light year, are all still technically working, still ticking upward, but they stopped meaning anything you could feel a long way back. That is the real break. Not that the numbers run out, that they keep going and stop landing. The few galaxies that do lie inside the Buta's void are not even spread evenly through it. They tend to fall along a rough tube running through the middle of the emptiness, which is part of why we think the void formed from several smaller voids merging, the way small bubbles join into one larger bubble. At its near edge lie the Hercules superclusters, dense gatherings of galaxies that form part of the wall around the hollow. So the structure is a great near-empty sphere, rimmed by crowded walls, with a thin thread of stray galaxies strung through the dark interior. And this is one void among countless others, each its own hollow in the web. We have looked closely at this one only because it is large and near enough to study. The emptiness it shows us is the ordinary condition of by far the most of space. Step far enough back and the picture these maps give us is the clearest single statement of what the universe actually is. The galaxies, every one of them, all the trillions, lie strung along a network of thin, bright filaments like droplets caught on a spider's web. And between the strands lie the dark hollows, the voids, immense and almost empty, taking up nearly all the room. The matter that shines, all the stars in all the galaxies, is a faint tracery on the surface of a structure that is overwhelmingly emptiness. We do not live in a universe of stars with some gaps between them. We live in a universe of gaps with a thin bright web of stars stretched through it, and we happen to sit on one strand of that web, easily mistaking it for the whole of things. The single cells of that web, one void with its surrounding walls, run to hundreds of millions of light years across, and the visible universe holds a great many of them, packed together like the bubbles in a head of foam. To cross from the center of one void to the center of the next is to travel a distance that makes the entire Milky Way, that 100,000 light-year span we struggled so hard to take in, look like a single grain of sand. We have climbed so far past the galaxy now that the galaxy itself, the thing that held hundreds of billions of stars, has become too small to even mark on the map we are drawing. Each rung up has done exactly that to the rung below it, made it vanish, and there are still more rungs above this one. Sit with that, because it is the floor dropping out. A galaxy at the center of that void would be so far from any other galaxy that, looking out with eyes and telescopes like ours, it would see only its own stars, and then darkness, and it would have every reason to conclude that it was the only thing in creation, a single island of light in an endless empty dark, with no neighbors anywhere. That is not a thought experiment about a strange far corner. That is what a typical resident of one of the universe's most common features, a void, would actually experience. The universe is not a crowded place that we are a small part of. It is mostly nothing, immense reaches of nothing, with the galaxies as rare bright flecks caught in the walls between the hollows. We are inside this web, in one of its denser strands, and we cannot even fully map our own place in it, or clearly see the mass that is dragging us across it. So the question turns here, at the center of everything we are doing. We have been asking how big the universe is. The better question, the one that turns out to be far worse, is how much of it we could ever actually reach. Everything we have climbed through so far, the Earth and the Sun, the 70,000-year gap to the next star, the 100,000 light-year galaxy, the 2 trillion galaxies, the superclusters and the voids, all of it fits inside a single sphere about 93 billion light-years across. That sphere has a name. It is the observable universe. And the first thing to understand about it is that it is not the universe. It is only the part of the universe whose light has had time to reach us. The number itself contains a puzzle worth stopping on. The universe is about 13.8 billion years old. Light travels at a fixed speed, so you would expect the farthest we could possibly see in any direction to be 13.8 billion light years, the distance light could have covered since the beginning. That would make the observable universe about 28 billion light years across, not 93. The reason it is more than 3 times larger than that simple figure is the single most important fact in this whole second half of the climb. Space itself has been stretching the entire time the light was travelling. The light set out toward us from objects that were close, and while it was in flight, the space between us and those objects expanded, carrying them much farther away. So the light arrives having travelled 13.8 billion years, but the things that emitted it are now around 46 billion light years away in each direction. The universe grew underneath the light as it came. And what sits at the very edge of that 93 billion light-year sphere is not a galaxy and not a wall and not an edge of anything solid. It is a faint glow coming from every direction in the sky at once, the same in all directions, a whisper of light at the very limit of what any instrument can detect. That glow is the oldest light there is, released when the universe was only a few 100,000 years old and cool enough for the first time to let light travel freely. It has been crossing space for 13.8 billion years to reach us, stretched and cooled along the way into a faint hum of radiation filling the sky. We call it the cosmic microwave background, and it is the closest thing the universe has to a visible boundary. That oldest light has a precise origin worth stating. For its first few 100,000 years, the universe was so hot and so dense that it was opaque, a glowing fog in which light could not travel freely, scattering off particles before it could get anywhere. Then, about 380,000 years after the beginning, the universe cooled just enough for that fog to clear, and the light set loose in that moment has been travelling ever since. That is the cosmic microwave background, the flash of the universe turning transparent, stretched by 13.8 billion years of expansion, from a fierce glow down to a faint cold hum, only a few degrees above absolute zero. It is less a thing sitting in space than a wall made of time, the earliest moment from which any light at all can reach us. We cannot see past it, because before it there was no free light to see by. And because looking far away means looking into the past, the deep universe is a record of how things used to be. The most distant galaxies in our telescopes are not shown to us as they are now. They are shown as they were more than 13 billion years ago, small and misshapen and newly formed, because that is the age of the light only now arriving. We are seeing the infancy of the universe out at its edges, held in light that has been crossing space since long before the Earth or the Sun existed. The galaxies that sent it have lived out their entire histories in the time that light has been travelling, and many of them are now among the ones we are about to find we can never reach. We see their childhood, and we will never know what became of them. The expansion has a measured rate, and it is one of the most argued over numbers in all of science. Space is stretching such that every span of about 3 million light-years grows by roughly 45 miles every second. That sounds gentle, and nearby it is. but it accumulates with distance without any limit, which is the whole reason the far parts of the universe race away so fast. And there is a deeper trouble in it. The two main ways we have of measuring that rate give slightly different answers that stubbornly refuse to agree. A disagreement serious enough that it may be pointing at something genuinely missing from our understanding of the universe. We can measure the expansion that is sealing us in. We cannot yet fully explain it, and the harder we measure, the less it adds up. The way we know any of this, the way we know the universe is expanding at all, is written in the color of the light. As space stretches while light crosses it, the light itself is stretched along with it, its waves drawn out toward the red end of the spectrum and past it. The farther the light has traveled, the more it has been stretched, and by reading how far a galaxy's light has been shifted toward red, we can measure how fast it is receding and how distant it is. The most remote galaxies are shifted so severely that their light has left the visible range entirely, stretched out of red and into the infrared and beyond, which is why catching the earliest and farthest objects takes instruments built to gather the stretched ghost of light that set out as an ordinary glow. That faint background glow was not predicted neatly and then confirmed. It was stumbled into, picked up first as an unexplained hiss coming from every direction in the sky that would not go away, a noise with no apparent source, until it was understood to be the cooled light of the early universe itself. It sits now at about 2.7 degrees above absolute zero, the temperature the whole universe has fallen to after 13.8 billion years of expansion. It is the most uniform thing we have ever measured, almost exactly the same in every direction, and the tiny differences within it, a few parts in 100,000, are the seeds out of which every galaxy and every structure we have climbed through slowly grew. When that light was set free, the patch of universe it came from was close to us, only about 40 million light-years away. In the 13.8 billion years since, the expansion has carried that same matter out to around 46 billion light-years from us. So the glow we receive as the edge of the observable universe comes from material that is now far beyond the reachable horizon, long gone, its light only now arriving as a cold whisper. The wall of the scene is built from the light of things that have since been swept past any hope of contact, which is the whole strange situation of this universe folded into a single fact. Even its farthest visible edge is a picture of somewhere we could never go. There is a cruel asymmetry hidden in the edge of the observable universe, and it is worth stating plainly. The observable part is actually growing. As time passes, light from ever more distant regions has had long enough to reach us, so the horizon of what we can see creeps slowly outward, and in that narrow sense we can see a little more of the universe each year. But the reachable part is shrinking at the very same time, as the expansion carries more and more of those visible galaxies past the point of no return. So the two move in opposite directions. We see a little farther as the years pass, and we can reach a little less. The universe is opening to our eyes and closing to our touch at once, and the closing is the one that matters, because seeing was never the same thing as arriving. And the sphere we see was once almost unthinkably small. The matter that produced the oldest light, now spread across 46 billion light-years in every direction, was packed into a region millions of times smaller when that light was set free. Everything in the observable universe, all 2 trillion galaxies worth of matter, was once crowded into a hot, dense glow with no structure in it at all, no stars and no galaxies, only a fog of particles and radiation. The great web of galaxies and voids we have climbed through grew out of the faintest unevenness in that fog, tiny ripples drawn out over 13 billion years into walls of galaxies and hollows, hundreds of millions of light-years wide. We are the late, cooled, clumped remainder of that early smooth fire. The newest instruments have pushed the edge of the scene almost back to the beginning. The most distant galaxies now confirmed are caught as they were only a few 100 million years after the universe began, their light stretched so far by the expansion that it has slid entirely out of the visible range and can be gathered only in the infrared. They appear small and raw and strange, the very first structures to light up out of the early dark. With these, we are looking nearly as far back as it is possible to look before the universe becomes that opaque fog, almost to the wall of the oldest light itself. And every one of those infant galaxies has, of course, long since been carried beyond any reach. We are seeing the universe's first morning, in light that took its entire lifetime to arrive. And the sphere we call the observable universe is not a picture of the universe at any one moment. It cannot be, because the light from farther away is older. Every shell of distance shows a different age of the universe. The nearby galaxies recent, the middle distances billions of years back, the farthest reaches almost at the beginning. To look out into space is to look down through layers of time, like the rings in a tree, the present near the center, and the deep past out at the rim. There is no way to see the whole sphere as it is right now, because right now at the edge is a thing whose light will not reach us for tens of billions of years, if it ever does at all. We see a single image of the universe, and it is assembled out of every era of its history at once. But notice exactly what kind of boundary it is, because this is where the difference between big and unreachable starts to open up. The cosmic microwave background is not the edge of what exists, it is the edge of what has had time to reach us. Beyond it, there is more universe regions whose light simply has not arrived yet, because there has not been enough time since the beginning for it to cross the gap. The wall of the scene is not a wall in space, it is a wall in time, the limit set by how long light has had to travel, and it tells us nothing about how much more is out there past it. We have measured the size of everything we can see. We have not measured the size of everything there is, and those two are not the same, and the gap between them is about to become the whole story. So that is how big the universe we can see really is. But there is a difference between what you can see and what you can reach, and in a little while I am going to show you why most of the galaxies in that 93 billion light-year sphere are places we can never touch, no matter what we build, no matter how long we wait, not even if we left today at the speed of light. The observable universe may be a tiny fraction of the whole, and the whole may have no end at all. The 93 billion light-years we just measured is not the size of the universe, it is the size of our view of it, and a view is not a thing in itself. The edge of the observable universe behaves exactly like the horizon you see standing on the ocean. The horizon is not the edge of the sea, it is just the limit of how far you, at your height, can see across the curve of the water, and the sea goes on well past it. The edge of the observable universe is the same. It is the limit of how far light has reached us, set by our position in time, not a boundary where the universe stops. So how much more is out there past our horizon? The honest answer is that we do not know, and we may never know, because by definition we cannot see it. But there are real measurements that point at the answer, and they point at something hard to absorb. When we measure the shape of space itself, by reading the patterns in that oldest light, space comes out flat to the very limit of our ability to measure it. And a flat universe is consistent with one that goes on without end, an infinite universe, the same kind of thing in every direction forever. If the universe is instead finite, curved so gently that we simply cannot detect the curve, then the measurements still force it to be enormous beyond the observable part, by the most cautious estimates at least 250 times wider than everything we can see. So the flaw under the question is this. The whole universe is at minimum hundreds of times larger than the 93 billion light-year sphere, and at most it is infinite, and we cannot currently tell which. There is one more thing to clear away, because people often picture the observable universe as a region we sit in the middle of, as though we were near the center of creation. We are at the center of our observable universe, but only in the way that you are always at the center of your own horizon at sea. Every point in the universe has its own observable sphere, 93 billion light-years across, centered on itself. A being in a galaxy on the far edge of our view has its own sphere reaching far past ours into regions we will never see, and considers itself the center just as reasonably as we do. There is no special place. There is no actual middle. Every observer is sealed inside their own bubble of visible space, and ours is no more central than any other. The finding that space is flat comes from reading the size of the faint ripples in that oldest light, the slightly hotter and cooler patches in the background glow. The size those patches appear to be tells us whether the space their light crossed was curved or flat. In the same way a triangle drawn on a ball has wider angles than one drawn on a flat table, every measurement we have made comes out flat to within a very small margin, and flatness, carried to its conclusion, points toward a universe with no edge and very possibly no end. The same kind of thing continuing in every direction without limit. If that is right, there is no outside to it, no boundary, no place where the universe stops and something else begins. There is simply more of it, on and on. An endless universe carries a thought that is hard to sit with. If space truly goes on without limit, filled everywhere with the same kind of matter, under the same laws, then everything that can happen does happen somewhere, an unlimited number of times over, far out past our horizon, beyond any possibility of contact. The arrangements of matter would eventually repeat, and there would be regions indistinguishable from this one. We cannot confirm that, and we cannot rule it out, because all of it lies in the part of the universe we are permanently cut off from. That is the honest shape of the unknown here. The universe may be infinite, it may contain endless repetitions of everything in it, and the one thing we can be certain of is that we will never be able to check, because the speed of light and the expansion of space have sealed those regions away from us for good. Where does that figure of at least 250 times come from? It comes straight from how flat the space measures. The flatter the universe looks, the larger it is forced to be, because a small closed universe would betray its curve, and we detect none. Push the measurement to the edge of its precision, and the smallest the whole universe can be, if it curves closed at all, is still hundreds of times wider than the part we can see, the part that already holds 2 trillion galaxies. So the cautious floor, the most conservative, honest estimate anyone offers, is a universe with well over 100 times the visible volume, and the ceiling is no ceiling at all but true endlessness. Either way, everything we have spent this entire climb measuring, the whole 93 billion light-year sphere, is at most a small bubble afloat inside the real thing. And there is no center to any of it, no special spot the whole thing is arranged around. We sit at the middle of our own observable sphere only because it is drawn outward from wherever we happen to stand, the way the horizon is always a perfect circle around you, no matter where on the open ocean you are. A being in one of those infant galaxies at the edge of our view sits at the center of its own sphere, reaching far past ours into regions we will never see, with every bit as much right to call itself the middle of things. There is no edge to stand at and no center to point to. There is only an endless or nearly endless sameness in which every observer is marooned at the center of a small bright bubble of the visible, with all the rest sealed away in every direction. I want to be careful not to oversell the part we cannot see, because it is genuinely unknown, and people are quick to fill an unknown with certainty. We do not know that the universe is infinite. We know that it is flat as far as we can measure, that it reaches far beyond our horizon, and that nothing in the data marks an edge or a center anywhere. Past that, honesty means saying that the size and the shape of the whole are not settled and may never be, because the evidence we would need is sealed away on the far side of a horizon we cannot cross or see beyond. What we can say is bounded, and what we cannot say is enormous, and the line between the two is itself one of the real findings here. The universe is at least hundreds of times larger than everything we can see, and how much larger than that is a question we may simply have to leave open. What all of this leaves us holding is a strange and specific kind of knowledge. Knowledge with a hard edge built into it. We can map our own observable universe in fine detail, weigh it, age it, trace its structure from the largest walls all the way down to single galaxies, and we can say with real confidence that it is not the whole, that it sits inside something far larger, but that larger thing is defined precisely by being the part we can never bring into view. So our picture of reality is complete in the middle, and frays into permanent ignorance at the edges, and there is no instrument and no patience that will ever mend it, because the missing part is not far away in the ordinary sense. It lies on the other side of the limit of seeing itself. It helps to be plain about what that flatness actually tells us, and what it does not. A flat universe is one where the ordinary rules of geometry hold across the largest scales, where parallel lines stay parallel, and the angles of an enormous triangle add up the way they do on a tabletop, rather than on a ball. That is what we measure, to high precision, and it rules out a small, tightly curved universe that closes back on itself anywhere near our horizon. What it does not do is prove the universe is infinite, because space could be flat and still finite, far larger than the observable part, but bounded in some way we cannot detect from the inside. So the measurement narrows the possibilities without closing them. It tells us the universe is at the very least enormously larger than what we can see, and leaves the difference between merely enormous and truly endless exactly where it was, out in the dark past the edge. This is one of the deepest open questions there is, and I want to state it plainly rather than smooth it over, because the not knowing is the honest part. Whether the universe is finite or infinite, whether it has an edge somewhere unimaginably far out, or simply continues without end, is a question we may never be able to answer from inside it. We are looking out from one point, with a view cut off by the speed of light and the age of the universe, trying to guess the size of a thing we can only ever see a piece of. So it is larger than we can see, perhaps beyond all limit. But the cruelest part of the scale is not the part we cannot see. It is the part we can see perfectly clearly, hanging right there in our telescopes, and can still never reach. Most of the galaxies we can see, we can never reach. Not with a better rocket, not with more time, not ever, not even if we left today at the speed of light. This is the hinge of the whole video, and it follows directly from the one fact that explained why the observable universe is so large. Space itself is expanding. Every region of space is gently growing, and the more space there is between us and a distant galaxy, the more of that growing there is to add up. So the farther away a galaxy is, the faster the expansion is carrying it from us. And this is not a small effect at the distances we are talking about. Past a certain distance, the expansion between us and a galaxy adds up to faster than the speed of light. That distance is called the cosmic event horizon, and it lies around 16 to 18 billion light years away. A galaxy beyond it is receding from us faster than light can travel. I want to be careful here, because this sounds like it breaks the one rule the universe does not break. It does not. Nothing is moving through space faster than light. The galaxy sitting in its own region of space is barely moving at all. It is the space itself between us and it that is stretching, and the stretching of space has no speed limit. Pile up enough expanding space between 2 points and they separate faster than light, while nothing local ever outruns a beam. The consequence is final in a way almost nothing in nature is. If we sent a beam of light toward a galaxy beyond that horizon, right now, today, at the fastest speed the universe permits, it would never arrive. The space ahead of it would open up faster than the light could close the distance, forever. The galaxy would never receive the signal, and nothing we could ever launch, no matter how advanced, could reach it, because nothing beats light, and even light loses this race. And here is the number that lands the whole argument. Of all the galaxies in our observable universe, the ones we can plainly see, whose light is arriving in our telescopes tonight, around 94% of them are already beyond that horizon. 94% already gone, already unreachable, already running from us faster than anything can follow. Only about 6% of the galaxies we can see could ever be reached, even by something setting out at light speed this instant. The other 94% we can look at, study, photograph and name, and never touch, not in a billion years, not in a trillion. Their light is a record of a past, a picture of how they looked when that light set out, of places that have since been carried so far away that the door between us and them is shut and locked and cannot be opened by any means physics allows. We can see them. That is all we will ever be able to do. The rule behind all of this is simple to state. The farther away something is, the faster the expansion carries it from us, in steady proportion. A galaxy twice as far recedes twice as fast. Keep moving outward and the recession speed keeps climbing, until at a great enough distance it crosses the speed of light. That is not a wall sitting in space. It is just the distance at which the stretching of all the space in between finally adds up to light speed and then passes it. Closer in, galaxies recede slowly and their light reaches us with ease. Far out, near the edge of the visible, almost every galaxy is already receding faster than light and has been for a long time. We see them at all only because of light they sent long ago, when they were nearer and the gap could still be crossed. So the image of a distant galaxy in a telescope is a kind of fossil. It shows a place as it was when the light left it, billions of years ago, and it says nothing about whether you could go there now, because for most of them the answer is no, and has been no for longer than the Earth has existed. The light is a message from a sender that has since moved permanently out of range, still arriving long after the door between us closed. We are surrounded in every direction by the old light of places we are already cut off from, a sky full of pictures of worlds we can never visit and in time will not even be able to see. Point to the deepest images we have ever captured, the ones crowded with thousands of faint galaxies in a single scrap of dark sky, and here is the hard truth folded into them. The great majority of the galaxies in those pictures are already beyond the horizon. We are looking right at them, studying their shapes and their colours, naming and cataloguing them, and not one of them could ever be reached by anything we sent, even at the speed of light, even setting out today. The deep field is not a map of places we might one day visit. It is a gallery of the permanently unreachable, a record of light from worlds that are, for any purpose that involves arriving, already gone. It is worth giving the small reachable part its due, because even that is enormous by any human measure. The 6% we could in principle still reach. The galaxies within about 16 billion light years number in the tens of billions, more galaxies than we could survey in the entire lifetime of our species, each one packed with hundreds of billions of stars. The reachable universe is not small. It is only small as a fraction. The point is not that we are penned into a cramped little space. It is that no matter how grandly we picture our potential, the part forever closed to us outweighs the part open to us by more than 15-1, and that ratio was fixed long ago and is only growing worse with time. There is a way to feel what happens to a beam of light trying to cross that expanding space, and it does not make the situation any smaller. Think of light as a swimmer moving at a fixed speed through water, the fastest swimmer there could ever be, and think of the space it crosses as a current. Near home, the current is slow, and the swimmer makes easy progress and arrives. But the farther out the swimmer goes, the faster the current against it runs, until at a certain distance the water is flowing backward faster than the swimmer can move forward. From there on, no matter how hard or how long it swims, it loses ground. It is carried backward while swimming forward at full speed. That is light trying to cross the universe toward a distant galaxy against the current of expanding space. The fastest thing there is, swimming as hard as anything can swim, and still going backward. This is why the wall is so complete, and why no advance in our technology could ever change it. The limit is not our engines, or our patience, or our cleverness. The limit is that even light, which needs no fuel and never tires and moves at the one speed nothing can exceed, cannot cross the widening gap. If light cannot make the crossing, nothing can, because nothing outruns light. The 94% is not beyond our current reach, the way a far shore was once beyond a person in a rowboat. It is beyond any possible reach for anything, forever, locked away by the deepest rule the universe has. There are two different limits worth keeping apart here, because blurring them hides the cruelty of the situation. One is the limit of what we can see, set by how far light has had time to travel to us, and that limit is far away and slowly growing. The other is the limit of what we can reach, set by the expansion, and that one is much closer and shrinking. The gap between the two is the heart of it. There is an enormous shell of universe that we can see perfectly well, galaxies hanging clear and sharp in our telescopes that already lies beyond the reach limit. We can study them in fine detail and never touch them. They are visible and unreachable at the same time, and there are far more of them than there are galaxies we could ever actually go to. This is about as close to a permanent verdict as physics ever delivers. Most things we call impossible are only impossible for now, waiting on a better tool or a cleverer method. This is not that. The galaxies beyond the horizon are receding because space between us and them is being made faster than light can cross it, and there is no tool and no method, none even in principle, that beats light or unmakes that space. When we say those galaxies are unreachable, we do not mean unreachable with present technology. We mean unreachable the way the largest possible number cannot exist by the structure of the thing itself. The door is not locked. There is no door. There is only more and more space, opening up faster than anything that exists can cross it. There is a final, quiet consequence of all this that I find harder to shake than the big numbers. For every galaxy now crossing the horizon, there will come a last photon, a final particle of light, the very last that will ever reach us from that galaxy across the widening gap. After it arrives, nothing more from that galaxy will ever come, no later light, no further image, because everything it gives off from then on is being carried away faster than light can close the distance. The galaxy does not wink out all at once. Its image simply freezes and reddens and fades, the final view of it stretching and dimming toward black, until that last photon comes in and the connection is over for good. Somewhere in the sky, we are receiving last photons right now. And so the sky is not the stable, permanent thing it appears to be on any human timescale. It is a slow tide going out, galaxy by galaxy, across spans of time longer than the Earth has existed. The lights are leaving, each one sending its last faint signal and then falling silent forever. We cannot watch it happen because it is far too slow to see, but it is happening without pause, and it has no end short of the empty future. The universe we can touch was always small. The universe we can even see is, very slowly, getting smaller too. And this is not a slow trickle at the far edges only. The reachable share of the universe is falling steadily, year upon year, as galaxies that today sit just inside the line of reach are carried just past it. Every one of them was, until lately, a place we could in principle have aimed for, and now is not. There is no announcement when a galaxy crosses over, no flicker you could catch from here. It simply passes from the column of the reachable into the column of the forever lost, quietly, by the millions, as the space between us and it tips over into growing faster than light can cross it. The wall is not a fixed line we are safely inside. It is a tide coming in, and we are standing on the shrinking beach. And this is the exact shape of the cruelty in it, stated as plainly as I can manage. The universe grants us the sight of itself and withholds the reach. It lets the light of 100 billion unreachable galaxies fall into our telescopes night after night, clear and detailed and full of worlds, and it has already arranged through the expansion that we can never go to a single one of them or send so much as a signal that arrives. We are allowed to look at very nearly everything and to touch very nearly nothing. The seeing is real and the barrier is real, and they sit side by side, and there is no version of the future, no advance, no patience that turns the one into the other. We will study those galaxies for as long as our kind lasts, and they will stay exactly as far beyond reach the entire time. There is a real uncertainty I should name, because it is the one place this could change. All of this rests on dark energy, the name we give to whatever is driving the expansion to accelerate, continuing to behave as it appears to behave now, as a steady, constant push. If dark energy were to change, the picture could shift. But on everything we can currently measure, the expansion is accelerating, the horizon is real, and the wall is not moving in our favour. So the honest situation is that we are sealed inside a small bubble of reachable space, watching a much larger universe that we can see and never visit. And it gets worse because the wall is not standing still. The reachable fraction is shrinking every single year. So what does that do to the universe over the long run of time? The universe is not only mostly unreachable, it is disappearing from view. The same expansion that put 94% of the galaxies beyond our reach is also, slowly and steadily, carrying the rest of them toward the same fate, stretching their light redder and fainter as they go, sliding them one by one toward the horizon past which nothing can be seen. The night sky we have, full of other galaxies, is not permanent. It is a phase, and it is thinning. Run the clock forward, and the picture becomes stark. As the expansion accelerates, every galaxy that is not bound to us by gravity is receding, and the light from the more distant ones is being stretched until it fades toward nothing. In the far future, on the order of 100 billion years from now, every galaxy outside our own immediate neighbourhood will have crossed beyond the horizon and vanished from view entirely. Our own local group, the Milky Way and Andromeda, and their small companions will by then have merged under gravity into a single large galaxy, and that one galaxy will be the only thing its inhabitants can see. Beyond it, in every direction, there will be nothing but dark. Think about what that means for anyone living then, because it is genuinely sobering. A civilization arising in that far future galaxy would look out with the best instruments they could build and see only their own island of stars, surrounded by an empty black sky. They would find no other galaxies, because there would be none left to find within reach of any telescope. They would see no expansion, because there would be nothing left out there to watch receding. Every clue we used to piece together the history and the scale and the expansion of the universe will have slid out of view. They would conclude carefully and reasonably and completely wrongly that their single galaxy was the entire universe, alone in a static, empty dark. The truth will still be true. It will simply no longer be visible, and there will be no way left for them to recover it. And this is not only a worry for the far future, because the erosion is already underway. Even in the next billion years alone, the fraction of the universe we could still reach drops from about 6% down to about 5%. A little more slides over the edge every year, quietly, with no event to mark it. Galaxies we could in principle have reached this year passing into the column of galaxies we never could. The reachable universe is a melting thing, getting smaller for as long as the expansion continues, which on present physics is forever. The fading happens in an order, from the outside inward. The most distant galaxies, already the faintest and the most stretched, redden and dim and slip away first, their light pulled to wavelengths too long and too weak for any instrument to gather. Then the merely distant ones follow, and then the closer ones, the horizon eating its way inward toward us across unthinkable stretches of time. The galaxies of our own local group are spared only because gravity binds them to us tightly enough to resist the expansion, holding them near while everything beyond drifts off. Everything not held down by gravity leaves. In the end, the sky empties of other galaxies entirely, save for the single merged island we will belong to. Far, I keep coming back to the strangeness of our timing in this. We arrived early, in the brief stretch of the universe's history, when the evidence of its true nature is still hanging in the sky for anyone who cares to look. The expansion is visible, the other galaxies are there to be counted. The oldest light still reaches us. A mind that comes along late, in that emptied future, inherits a universe that misleads it, a single galaxy in a black and motionless sky, with every clue to the larger truth already carried beyond reach. We tend to picture ourselves as latecomers in an old universe. By the measure of what can still be seen, we are early, and the fullest view there will ever be is the one we happen to be holding right now. Run the clock far enough forward, and the emptying of the sky is only the start of the universe winding down. The gas that builds new stars runs low, and star formation slows, and then all but stops. The brightest stars burn out first, then the middling ones like the sun, until only the small dim red stars remain, glowing feebly for trillions of years before they too go out. The universe drifts toward cold and dark, the galaxies that are left populated by dying embers, and then by the black remnants of stars, spread through a space that never stops expanding. The age of starlight, the one we happen to live in, is a brief bright chapter near the very beginning of a history that runs overwhelmingly toward darkness. Which means the view we have now is not only early, it is close to the finest the universe will ever offer. The galaxies are still lit, the sky is still full of them, the evidence is still here to be read. Far enough into the future there is steadily less to see in every direction. Fewer stars burning, fewer galaxies in reach, the whole spectacle dimming toward its end. We did not arrive at a special place in space, where every point is as ordinary as every other, but we may well have arrived at a special time, near the peak of what there is to witness, in the window before the long fade carries most of it out of sight for good. Put rough numbers on the fade, because they carry their own vertigo. In something like 100 billion years, the last galaxies outside our own will have crossed beyond the horizon and vanished. In a few trillion years, the last of the bright stars will have burned out. In spans far longer than that, times written with so many zeros that the words for them are almost never used, even the dimmest red stars will gutter and die, and the universe will be a cold scattering of dead stars and black holes adrift in an ever emptier dark. Against those numbers, the 13.8 billion years the universe has existed so far is not the story, it is the opening line of it. The brief lit beginning before the long darkness that makes up nearly all of what is to come. We are living, then, in the early morning of the universe, while the lights are still on. Every star you can see, every galaxy in every image, the whole crowded shining sky, belongs to a brief opening chapter. It will not always be possible to look up and find other suns, let alone other galaxies. There is a window, right now, in which the universe can be seen more or less as it truly is, full and lit and readable, and we happen to have been born inside that window. It will close. The seeing we are doing tonight is not a permanent condition of being alive in this universe. It is a privilege of the early, and we are the early ones. Follow that winding down to its end, and the universe becomes a place almost without events. After the stars have died, the galaxies that remain are dark, holding the cold husks of burned-out suns and the black holes that slowly grew at their centres. Over spans of time so long that the numbers lose all footing, even the black holes evaporate, bleeding away into faint radiation until they too are gone. What is left is a thin, cold, still expanding dark, growing emptier without end, settling toward a uniform near nothing that simply persists. That is the direction the universe is heading on everything we currently understand, and it is the overwhelming majority of its future, against which the bright age of stars is a brief flare at the very beginning. I do not raise this to frighten anyone, and I do not think it should be frightening exactly. It is the far end of the same measurement, the one that began with the Earth set against the Sun. The universe had a beginning whose light we can still catch. It has a present that is full and bright and legible, and it has a future that runs long and dark and quiet. We are near the beginning, in the lit part, in the short stretch where the whole structure can still be read off the sky. That is not a tragedy, and it is not a gift. It is a fact about when we happen to exist, and like the size of the Earth, it is best looked at directly rather than turned into a comfort or a warning. In time, even the oldest light goes. The cosmic microwave background, that faint glow from the moment the universe became clear, is itself being stretched by the expansion, its waves drawn longer and fainter as the eons pass, until in the far future it will be too weak and too stretched for any possible instrument to detect. The last evidence that there was ever a hot beginning, ever an expansion, ever anything at all beyond a single dark galaxy, will fade out of reach along with everything else. The universe is not only carrying the galaxies out of view, it is erasing the record of its own history, slowly and almost completely, leaving a future in which the truth is not merely unknown but unknowable, every clue gone. We hold those clues now. That, more than anything, is what makes now different from what is coming. And there is a loneliness in that future worth naming directly. A civilization in the emptied universe would not only lack the galaxies, they would lack the very clues that let us reconstruct where we came from. We worked out the age of the universe, the expansion, the hot beginning, by reading light from far away and long ago. Strip that light out of the sky, and the questions become unanswerable, not because the minds of the future are any less capable than ours, but because the evidence itself is gone. They would stand under a black sky with one galaxy in it, and no way even to suspect that anything else had ever existed. We are, by the accident of our timing, among the last who will be able to see the universe clearly enough to understand it, and among the first who could. The window of understanding is not only open now. It may be that in the long life of the universe it is only ever open now, near this one early stretch of a history that runs mostly dark. Which leaves us, the people alive now, in a strange and specific position, and I think it is worth saying plainly what it is. We happen to be living early, in the window when the evidence is still in the sky, when the other galaxies are still visible, and the expansion can still be read, and the true scale of things can still be measured. Later observers lose all of that, permanently. We are not at the center of the universe and we are not large in it, but we are early enough to see what later minds will not be able to see at all. So we are sealed in a shrinking bubble, with the doors quietly closing one by one. The only question left is what it means to be here, in this now. Set against all of this, the Earth is not small. It is beyond small, past any honest word we have for size, and the cleanest way to show it is to go back to the measuring stick we started with and look at it from a distance. In the year 1990, the Voyager 1 probe, on its way out of the solar system, turned its camera back toward home from about 3.7 billion miles away and took a photograph of the Earth. In that image, the entire planet, everything that has ever happened, came out as less than a single pixel, a pale dot less than 1 point of light across, caught by chance in a stray band of scattered sunlight. And that picture was taken from inside our own solar system. 3.7 billion miles is nothing on the scale we have been building. It is closer than Voyager had even reached on its way to the first gap, far nearer than the nearest star, unimaginably nearer than the galaxy or the galaxies beyond it. From just that distance, from inside our own backyard, the Earth was already less than a single dot. Now carry it outward. Against the 4 light years to the nearest star, the Earth is nothing. Against the 100,000 light years of the galaxy, it cannot be conceived of as a size at all. Against the 93 billion light years of the observable universe, the Earth cannot be placed on the map. Not as a pixel, not as a speck. There is no scale you could draw of the universe on which the Earth would occupy any room whatsoever. It rounds, exactly and completely, to nothing. And every human being who has ever lived has lived on that dot. Every person you have known, everyone who has ever been born or died, every life and every death and everything anyone has ever done, all of it on that single pale point that was already invisible from inside our own solar system. One speck in one ordinary galaxy, which is one of perhaps 2 trillion, in the 6% of that we could ever reach, in the part of the universe we happen to be able to see, of a whole that may have no end. Stack the fractions, and the Earth is a vanishingly small part of a vanishingly small part of a vanishingly small part, all the way down. That photograph was taken because one astronomer asked for it, requesting that the probe turn its camera back toward home, one last time before its view of the Earth was lost for good. What it caught was almost nothing, a dot less than a single pixel wide, hanging by chance in a shaft of sunlight that had scattered inside the camera. There is no detail in it. You cannot pick out a coastline, or a cloud, or any feature at all. There is only the pale point, smaller than the stray glare around it, and the knowledge that this point holds everything that has ever happened to our kind. Photographed from a distance that is, on the scale of this video, no distance whatsoever. Stack the fractions honestly, and the smallness compounds past any feel for it. The Earth is one minor planet of one ordinary star. That star is one among several 100 billion in a single galaxy. That galaxy is one among hundreds of billions, perhaps trillions. Of all those galaxies, only about 6 in 100 are reachable, even in principle, and all of them together are merely the part of the universe near enough to have ever been seen, set inside a hole that may run on without end. Multiply those shrinkings one by one, and the place we live, the entire stage of every human life that has ever been lived, comes out smaller than there are honest words for. Not small the way a person is small in a crowd, small the way a single grain is small against an ocean, and then even that comparison breaking, because it does not come anywhere close to small enough. So what do you do with a measurement like this one? Not despair, I think, because despair is a response to losing something, and nothing here has been taken from you that you ever had. You were never going to walk in another galaxy. The 94% was never within reach to begin with, so its being sealed away costs you nothing you could have used, and not comfort either. No tidy lesson about how all this makes our small lives precious, because the universe is not arranged to teach us anything, and does not bend itself to make us feel better about our place in it. What is left when you set aside both the despair and the false comfort is the seeing itself, clear and unflinching, the plain fact of where and what we are. I have come to think that has a worth of its own, separate from whether it consoles, and it is most of what this whole climb was for. And so we come back to where we began, to the Earth as the measuring stick, except that now we know what it measures against. We held it up to the sun and it vanished. We held it up to the galaxy and it disappeared past any sense of size. We held it up to the universe and found it could not be placed on the map at all. The climb is finished. There are no more rungs above this one. We have gone from the ground under your feet to the edge of the seeable, and then past it into the part that may have no end, and at every step the Earth, and we standing on it, grew smaller, until small stopped being a word that helped. What is left is to say plainly what I have come to think all of it amounts to. If there is anything to hold on to in all of this, I do not think it is reassurance, and I do not think it is dread either. It is that we are, so far as we can tell, the part of the universe that has worked out its own size. The matter on this one dot organized itself into something that could measure the distance to the galaxies, read the age of the oldest light, and follow the expansion all the way out to the wall that seals us in. The universe is overwhelmingly large, overwhelmingly empty, and mostly beyond our reach, and a thin smear of it on a single pale speck managed to figure that out. That does not make us important. It does not have to. It is only the strangest true thing I know about our place out here, and it seemed worth saying once, plainly, before the end. Hold the whole chain in mind at once, because it is the measurement this was all for. You are on a planet that is a speck beside its star. That star is one ordinary point among several 100 billion in a galaxy so wide that light takes 100,000 years to cross it. That galaxy is one among hundreds of billions, perhaps trillions, strung through a web that is mostly empty dark. The part of that web we can see is a bubble 93 billion light-years across, and it sits inside a hole that is at least hundreds of times larger and may have no end at all. And of everything in even the bubble we can see, more than 9 in every 10 is already sealed away from us forever. That is the address, that is where this is, written out in full, from the ground under your feet to the edge of the possible. I want to be careful about what this is and what it is not, because it would be easy to turn it into something it is not. This is not a setup for despair, and it is not a setup for comfort either. It is not a lesson with a tidy moral on the end of it. It is simply the measurement, carried all the way out to where it ends, and then faced honestly instead of looked away from. The Earth really is that small against the real size of things. We really are sealed on it, on one dot, able to see a universe we can almost entirely never touch. Those are not feelings. They are the findings, the plain result of climbing the ladder rung by rung until it ran out. So before I tell you what I have come to make of all of it, let the measurement stand on its own for a moment, the honest size of the Earth set against the honest size of the universe, with nothing laid over it to make it easier. I keep coming back to the light. We started with it as the fastest thing there is, the ruler we hold up against everything, and by the end it turned out to be too slow to cross our own galaxy in less than 100,000 years, too slow to ever reach the 94% of galaxies that are already running from us faster than it can travel. The fastest thing in the universe, losing the race to nothing but empty space getting larger. When I started looking into this, I thought the size of the universe was a fact about how much there is. I have come to think it is really a fact about how alone we are. Almost everything that exists, we will never see clearly, never reach, never touch, and a great deal of what we can see is leaving quietly every second, sliding past the edge of what light can ever deliver. One day there will be skies with nothing in them but a single galaxy that believes it is the whole of creation, and no way left to know any better. We happen to live early enough to still see the rest, to still hold the evidence that there is more out there than our one island of stars. That window is open now, and it is closing. So when I look up, I do not feel small the way you feel small in a large room. I feel sealed in, on one speck, in one galaxy, in the thin sliver of everything we could ever reach, watching the rest drift away. That is the honest size of the universe. Not how much room there is, how little of it was ever ours. If you want to keep sitting with questions like this one, you are welcome here any night, and a subscribe keeps the next one close. Sleep well.